Nitinol is an exciting engineering material that has found many uses in a variety of fields. Many applications using nitinol require that the nitinol part be joined either to another nitinol part or to a part made of a different material such as stainless steel. In many cases, soldering is the best joining option and can form a sufficiently strong bond. The titanium oxide that readily forms on the surface of nitinol materials and gives it its excellent corrosion resistance inhibits the ability of most solders to wet the nitinol surface and make a strong solder joint. To get around this problem, there are a number of different techniques that have been explored to solder nitinol. Some have tried plating the nitinol with a more solderable material such as nickel, but with mixed results. Often there is a problem with poor adhesion of the plating material to the nitinol. Others have tried ultrasonic soldering techniques, which can be an effective fluxless technique for many hard-to-solder materials. Good joint strengths have been obtained with this technique, but ultrasonic solder joints may contain more residual oxides than flux joints, and the equipment may not be available in all manufacturing or laboratory facilities. Some of the halogen-based fluxes that were originally developed for use with aluminum alloys have proven to be effective for soldering nitinol. However, a U.S. patent was issued to Cook Incorporated in 1993 that appears to cover this approach and may restrict its use for many applications. Shape Memory Applications has developed a proprietary flux, Nitinol Flux 400, that has proven to be effective at producing strong solder joints with nitinol. The remainder of this video will provide instructions for reliably producing good solder joints using this flux. This video will provide basic instructions for soldering nitinol. Written instructions are contained in the nitinol soldering kit, along with many of the basic supplies you'll need. First, we'll review the basic equipment and supplies you'll need. Second, we'll discuss some important safety considerations. Next, we'll review the procedures to clean and prepare the surfaces to be soldered. Then, we'll discuss specific techniques for soldering nitinol with a soldering iron or a solder dip pot using nitinol Flux 400 and a standard tin silver solder. Finally, we'll review some techniques for cleaning the joint after soldering to remove any excess flux, residue, or other contaminants. To solder nitinol, you'll need the following. A 320 to 600 grit abrasive paper may be used for cleaning the visible oxides from the nitinol surface prior to soldering. A good alternative, though not always available to everyone, is a strong etchant, such as a mixture of nitric and hydrofluoric acids. Such a mixture is commonly used to etch nitinol to remove the natural oxide layer. If the nitinol has already had its visible oxides removed through grinding, etching, or polishing, further surface preparation may not be required. A bottle of nitinol Flux 400 is included in the nitinol soldering kit. Please be careful. Nitinol Flux 400 is made of strong acids, is corrosive, and may burn skin upon contact. Depending on the application, a number of methods may be used to apply the flux to the materials to be soldered. The nitinol soldering kit contains a dropper and a small brush. A syringe, which has been specially designed for fluxes, can also be used. A spool of a standard tin silver solder is included in the nitinol soldering kit. More of this type of solder can be readily purchased from any industrial solder supplier. We recommend a soldering iron with a variable temperature control. Be sure to have good clean tips for the iron. Alternatively, a solder dip pot can be used for some applications. It's helpful to have some type of fixture to hold your parts in place, so you have both hands free for soldering. Copper wicking material provided in the nitinol soldering kit may be useful for removing excess solder from the joint. This product can be obtained from any industrial solder supplier. Isopropyl alcohol is recommended for cleaning the joint before and after soldering. Alternatively, distilled water may work in many applications. You'll be working with strong acids and hot materials, so safety is very important. These safety instructions are not intended to be 100% comprehensive, but are simply reminders of some of the important safety considerations. Please consult the appropriate company and local government lab safety guidelines for working with acids and hot materials. Wear safety glasses. Appropriate eye protection is always necessary when working with dangerous materials. Be sure that your work surface is appropriately heat resistant and that all heat-sensitive or flammable items are removed from the work area. Nitinol Flux 400 is a strong corrosive acid. Avoid all skin contact, ingestion, and inhalation. Follow the same precautions that you would follow when working with any strong acid solutions. You may wish to keep a supply of baking soda handy to neutralize any spilled flux. The solder and the iron are both very hot. Please be careful to avoid touching them or any hot sections of the work pieces. To achieve a strong solder bond, the surfaces to be joined must be clean and oxide-free. The best way to achieve such a surface is with a flash etch, using a solution such as a combination of nitric and hydrofluoric acids. A typical mixture used for nitinol consists of 5 parts nitric acid, 1 part hydrofluoric acid, and 15 parts distilled water. Do not etch the materials for too long or you may risk embrittling the nitinol. A few seconds should be enough to remove the visible surface oxides. When etching is not feasible, a strong bond can still be achieved using a mechanical cleaning, such as light sanding with 320 or 600 grit abrasive paper. After removing the visible oxides, the surfaces should be rinsed thoroughly with isopropyl alcohol or distilled water prior to soldering. Once you've cleaned the parts, you're ready to solder. Make sure that all of the necessary equipment and supplies are within easy reach. If your soldering iron has an adjustable thermostat, set the temperature to 600 degrees Fahrenheit or 315 degrees centigrade. Clamp the workpieces in place so that you'll have both hands free. The two materials to be soldered should be positioned accurately so they can be soldered without further adjustment. Clean the soldering iron tip on a moist sponge. These sponges are typically included as part of the soldering iron equipment. If your soldering iron does not include one, any moist sponge will do. Wet the solder with a drop of Nitinol Flux 400. Hold the soldering iron in one hand and melt a length of tin silver solder onto the tip of the soldering iron. Enough to coat the tip of the iron is sufficient for most joints. With your other hand, get ready to apply a drop of flux to the workpiece. Fill your syringe or dropper, or dip your brush into the flux. Wait for the next step before actually applying the flux. Heat the workpieces by holding the liquid bead of solder on the tip of the iron against the area to be joined. At this point, the solder may not flow because the flux has not yet been applied. Quickly remove the soldering iron, apply flux to the entire area to be joined, and immediately bring the soldering iron back into contact with the workpieces. Generally, 1 drop of flux is enough. When the solder begins to wet onto the workpieces, slowly and steadily move the iron along the length of the joint. As needed, apply solder from different angles by touching the drop of liquid solder on the iron tip to the joint. In each instance, wait for the solder to begin wetting, then slowly draw the tip of the soldering iron along the length of the bond. An alternative soldering method is to use a solder dip pot. Once again, you should start with workpieces which have been prepared using a flash etch or abrasive paper. Set the temperature on the dip pot to 600 degrees Fahrenheit or 315 degrees centigrade. Melt a quantity of tin silver solder into the pot to a depth sufficient to cover the length of the desired joint. Clamp workpieces in a fixture that will hold them in the proper position with respect to each other for dipping in the solder pot. Apply flux to the workpiece. Wipe the oxide from the surface of the dip pot with a skimmer. Slowly dip the workpiece into the dip pot, then withdraw it. Repeat the flux and soldering steps as needed. Visual inspection is not a foolproof test for solder bond strength, but it does provide a rough indication of joint quality. In general, strong bonds are shiny and smooth with no pits, gaps, icicles, or other irregularities. After the workpiece has cooled, rub the solder joint between your fingers in warm water for approximately 1 minute. As an extra precaution, you may want to rinse the bond area with isopropyl alcohol. If you've spilled any of the Nitinol Flux 400, promptly neutralize the spill with baking soda. With some practice, you should be able to consistently produce strong solder joints with Nitinol. These techniques and variations on them work well to join Nitinol to other Nitinol parts as well as to stainless steel and many other materials. To learn more about Nitinol materials and manufacturing methods, or to obtain additional Nitinol soldering kits or Nitinol Flux 400, please contact Shape Memory Applications. For further information on soldering Nitinol materials, we recommend the following references.